Here's a couple more 3x3 matrices, system of equations with three variables, and then change it to a 3x3 matrix and then solve it. So number 5 and number 6 on this page, I'm going to cover those two. So a bicycle, 3 tricycles, and a unicycle cost $561. 7 bicycles and a tricycle cost $906, and 5 unicycles, 2 bicycles, and 7 tricycles cost $1,758. Find the cost of each type of cycle. So we're going to let X equal the cost of the bicycle, Y the cost of the tricycle, and Z the cost of the unicycle. So the first sentence, 1 bicycle, 3 tricycles, and a unicycle cost $561. I change it into this math sentence here. And then the second sentence, 7 bicycles and a tricycle. And then there's no unicycles there, so equals 906. And then 2 bicycles, 7 tricycles, and 5 unicycles cost $1,758. So changing that to a matrices is 131, 710, and 275. And here's your variables X, Y, and Z. And here's your right-hand side of the equation, 561, 906, 1,758. So now I'm going to go to my calculator. And I'm going to go to my matrix, Desmos matrix calculator. And I'm doing a new matrix, a 3x3, add it, and 131. So 1, 3, and 1 is the first row. Second row, 710, 710. In the third row is 275. And then matrix B, whoops, I'm going to do new matrix, which is a 3x1. And it's going to be matrix B, 561, 906, 906, and 1758. And I want to do A inverse times B, and I get 117, 87, 183. And those are right here. 117 for the bicycle, 87 for the tricycle, and 183 for the unicycle. Okay, and then number 6, if I look at that one, a florist is making 5 identical bridesmaids bouquets for a wedding. She has 610 to spend, and she wants 24 flowers in each bouquet. So roses cost $6 each, tulips $4, lilies $3. She wants to have twice as many roses as the other 2 flowers combined in each bouquet. How many roses, tulips, and lilies are in each bouquet? So X is the number of roses, Y the number of tulips, and Z the number of lilies. So if I have 6 bouquets and 24 in each, I mean 5 bouquets and 24 in each, is 5 times 24 is 120. That's where I got this number. So I did 5 identical bouquets with 24 flowers in each would be a total of 120 flowers. So the number of roses plus the number of tulips plus the number of lilies has to equal 120. And then the dollar amounts for each is $6 for a rose, $4 for a tulip, and $3 for a lily. And she has $620 or $610 to spend altogether. And then the last sentence says she wants to have twice as many roses, so X is going to be 2Y plus 2Z, or this equation right here. Whoops. Let me take that mark off there. This equation becomes X minus 2Y minus 2Z equals 0. So I could put it in the matrix that way. So 1, 1, 1, 6, 4, 3, and then the coefficients here are 1, -2, and -2. And I have 126, 10, and 0 in this matrix. So now going to my calculator. So let me go ahead and clear it. So I'm always doing A inverse times B. So new matrix, a 3 by 3, and then 1, 1, 1, 6, 4, 3, 1, 1, 1, 6, 4, 3, 3, and the last row is 1, -2, -2. Okay, and hit enter. That's matrix A. Matrix B is 1, 10, 6, 10, and 0. It's a 3 by 1. 120, 6, 10, and 0. So now I want to do A inverse times B. And I get 80 roses, 10 tulips, and 30 lilies. So if I add these two together, that's 40 flowers, and twice that is the 80 roses. So you got twice as many roses as these two added together. And if I plugged into the other equations, then it would make all three equations true. If I plugged in 80, 10, and 30. So back here, I have 80 roses, 10 tulips, and 30 lilies. So the reason why I want to go over these two here, because I think the check for understanding matrix is a 3 by 3. And then you have to set it up and then solve it. So I wanted to go over at least two more 3 by 3 matrices. How to set up the equation, how to change it to a matrix equation, and then how to solve it on the calculator.